Hello, welcome to episode 9 on the series of Introduction to Programming. Previously, we looked at numbers, but computers have a lot of different formats that we can use for numbers. So in this video, we're going to take a look at some of the less common formats you may encounter when working with JavaScript. Of course, starting off, we'll go to our normal numeric way of describing numbers, which is variable x equals the number 3, right? If I run this, you'll see that it spits out the number 3. Nothing exciting going on here. But there's other formats that we could use. So we can type out decimal numbers. Decimal numbers are, a simple number with a decimal symbol in the middle of it that indicates when we switch from whole numbers to fractional numbers. And so in this case, I can spit it out, give me 3.14, which is very common way that we will describe non-integer values, right? When we're dealing with certain formulas, if we're dealing with some types of measurement units, we will most likely need decimal numbers at some point. If you're dealing with just like counting, you're of course not really going to need to use decimal numbers, but they do show up fairly often. Other and slightly more complicated formats we have is we have the exponential notation. So in this case, we can basically write 3e3. What the heck is 3e3? Well, 3e3 is the equivalent of 3 times 10 to the power 3. Right, run this, 3,000. So exponential notation is common if you're dealing with more scientific values or you're trying to do like simple computations, maybe related to physics. If you're doing this in JavaScript, you may use exponential notation. You can also have a negative value here, right? So if I run this, and it'll be, 3,000ths instead of 3,000, right? So exponential notation can be useful for describing small, large numbers. You can also put a decimal point after this, right? So if I want to run this, it'll spit it out. Nothing too fancy going on here, but it is a format that you will encounter probably less often unless you're dealing with a very scientific or type of concepts or type of program that's dealing with a lot of computations. You also have other formats that are more useful for programming. Hexadecimal numbers are a type of number that we use when dealing with lower level languages. You'll probably encounter them if you're dealing with code that needs to send data or possibly interpret like error codes. Those are a couple cases where you might use hexadecimal numbers. So hexadecimal numbers start off with OX, and then you have base 16. Right. So if I run this, you'll get obviously not 123 because this is not 123. This is 1, 2, 3 in hexadecimal. Right. Hexadecimal A to F are also valid digits. Right. Which spits out quite a bit bigger of a number because, again, it's a different format. Displaying it as decimals is a little bit odd, and often if you want to display something in hexadecimal, you will type out, or you will tell the number x to convert itself to a string value using base 16, right? So if I run this, it actually spits it out as a hexadecimal number. But that's not the only other format that used in programming. So we also have binary numbers, which we will start off with 0b in JavaScript. And I can spit out a binary number. I'll convert x to actually be a string in binary. And again, if I run this, we'll see that it is a binary number. If I'm not converting it first to binary and I just run it out, it's number 42, right? So binary can be a very useful format when dealing with lower level operations, especially if you're dealing with server-side JavaScript. You probably will want to deal with a few things in binary. Having a binary as a notation for writing numbers can be very handy for this. I will probably get into binary or bitwise operators in a future video, but for now, just know that you can actually write numbers in binary in JavaScript. But there is a other number format that I haven't talked about called octal. Now, if you don't know what octal is, consider yourself lucky. If you do know what octal is, I'm sorry for your loss. But we can define octal numbers, which are base 8 numbers, starting with a 0, 2, 3, 4. So if I run this, it's not going to display 2, 3, 4 because this is octal, right? If I drop this leading 0 here and run it, it is now a decimal number. If I put a leading 0, it is now an octal number. And this can be a major source of bugs when dealing with JavaScript or web development, is when somebody puts a leading 0 on a number, not realizing that it changes the meaning of this number. This number is no longer 234. This is a octal 234. An easier way to convey that you intended to do it is to put like a O after the 0. So if I run this again, it'll continue to be octal. If I drop these two, it's just a decimal number, right? So if you are going to deal with octals, a common convention in newer versions of JavaScript, oh, I guess I thought uppercase O counted, but apparently not. So only lowercase o's after the 0 is considered an octal number. And again, if I want to actually display it in octal, we can convert it to text in octal format, and you will see an octal number. So given all of these, let's spit out all of the values here. Probably drop. Oh, I can probably drop the X part. Do that. Do OB0010. Oh, interesting. That might not run. Oh, no, that does. The highlighter has a problem here. Ah, we don't have to worry about that, thankfully. So I can also do 2, 3. Exponential notation. Four. And finally, what we started with originally is just the number 3. So if I spit it all out, you can see all the different types of formats that you are able to work with. So hopefully you found this interesting and informative. Have a good day.